good time. Come and have a good time. Come and have a good time.
Hello, and welcome to another Air Code 429 tooling video. Today we'll be talking about configuration management and the ConfMan Python tool that I've created and implemented to secure EC 429. So quickly, what is configuration management or secure configuration management? SCM is a security technique for ensuring file integrity for secure and important files that you would like to keep static over time. So basically, when you think about your web server or your file system, firewall, or any other operational technology that you have in your environment where that machine does one single purpose, and that purpose has configuration files or secure files that shouldn't change over time. So let's think about one example is an Apache web server. That Apache web server is doing one job. It's serving files to the web, right? And that web server has secure files or configuration files that shouldn't change over time. You configure the server in one way, and you're expecting that that configuration stays consistent. So day after day after day, that configuration shouldn't change. And if it does change, then you want to be aware of that. Likewise, if there's, for your firewall, if you write the firewall rules, you're expecting that those firewall rules don't change. And if they do change, you want to know when they changed, who changed them, and what the changes are. You can imagine an example of an attack where the attacker finds his way into the environment and they go to the firewall configuration and they modify the actual firewall rules to allow for new inbound traffic to come in, new outbound traffic to come in, or anything else. So you really want to be able to track these static files in your environment to ensure that they are the same over time and that they haven't been manipulated. And when they are manipulated, you want to know when and by who. So this practice of monitoring these files is called configuration management. And there are a lot of tools out there that do this purpose, but I wanted to create my own program in-house just so the code base would be a little smaller, it would be free, and it was just something that I could do on my own. And you really don't need too much of you don't really need that big of an application to implement configuration management. It's something that's relatively easy to do, so I thought, why not create a program on my own? So that's what I've done. I have created the ConfMan Python tool, which does the exact purpose that I've described. So I'll show you the help menu. So Python3, confman.py, help. So basically it's a command line tool that has 4 different functions, and I'll go through those throughout the video. The first being a baseline. So the program, the Python tool, will take a file, it'll take an argument for the file path, and then it will take a baseline name. So you'll give it the file path, you'll give it a baseline name, and then you'll say who is approving this new baseline. So a baseline in configuration management is the known state of the file. So I'll give you a quick example. So what I've gone ahead and done is change directory to my Apache directory. And as you can see, there are some files in here. And one of the configuration files, I'll go ahead and open up. So this is a good example of a configuration file. It has different settings. It has a root directory. It says what users can be involved, what modules to load, and a lot more. So this file should not change over time. So what's typically done in configuration management is to take a hash of a file. So we can quickly do an MD5 sum of the file and get the particular hash. Now this will not change over time if the file doesn't change. However, if you modify that configuration file, even just a space or one character, anything will completely change this hash to something else. So let's create a test file to prove this point. I've created a test file called test file, and I'm writing test file into it. Okay, so we can see that when we give the output of test file, it's test file. So let's go ahead and do a hash of this file. You can see it right there. If we change the file to say new test file, save it, run it again, this hash and this hash are completely different, which is to be expected. We've gone ahead and changed the file. We change it back, run it again. Now we can see the new hash is original to the hash that we took when we originally wrote it, because now all of the characters are exactly the same. So this is one of the elements of hashing a file. So for the tool, let's go ahead and hash a file and see what happens. So I'm going to go ahead and say, call the program, Python3 ConfMan. I want to do a new baseline, and it takes 3 arguments. It needs a file path. So let's get out of this configuration and just go to the temporary directory. And let's go ahead and just do the same thing of making a test file here. Okay, so we're in temp, and it's called test file. So let's give temp test file as the path. We're going to do the baseline name as test file, and we're going to make the approver as me. Hit enter, and we get an output saying we've run the configuration baseline function. We have a successful baseline taken. The file was created here. The baseline name is test file. The baseline date was just now. It was approved by me. And here is the baseline hash. Okay, that's awesome. So as you can see, it's stored in the managed directory. So I could cd into the managed directory, but I've already done that. And then when we go to the managed directory, you'll see the test file was created as a JSON file. So if we open the test file, and I'll use the Python3 module JSON.tool so we get some better output. We see that the JSON file contains JSON objects from the baseline that we just performed. So when we perform the baseline, it gives us this nice output, but then it also stores that output in a JSON object in the managed directory file. So we have the name, the path of the file, when it was established, the approver, the baseline, and then we have what's called checks. And I'll get into that just in a second. but the check has a child object which says the date and the hash that was taken. So if we go back into the directory containing the Python program, let's go ahead and bring up the help menu again. So the next thing we want to do is an audit. So an audit will perform a check of the file again. So what we've done is we've taken a baseline, and then we can perform an audit or a check to say, is the hash still the same as the original baseline? And the audit function only takes the baseline name, which when we created the file was called test file. So let's run the program. What we want to do is an audit of test file. Okay, so we've done another audit, successfully done the audit function of the file audited, what the name was when we did the check or the audit, and then the baseline hash. So if we go here to our manage file again, we can see that we performed another check of the file. This was created from our baseline. This was created from our last audit. If we run this again, we get success again. Now we have 3. So we just checked it at 1041, 1044, and 1045. This is great. Now we can check it however often we want. We can check it daily, we can check it hourly, we can check it weekly, and we can ensure the integrity of the file has not been changed. Now, what can we do to see if it's changed? How can we detect a change? Well, we have this built into the tool as well. We have the detect function. This will actually perform, like it says, perform a configuration change detection. So all this needs is we'll call Python3, call the program, and it takes the baseline name, which we've set as test file. Let's go ahead and say we want to detect. And then we get a nice little banner as well saying configuration identification function has run. We get the file, the baseline name, the baseline date when it occurred, who was approved by, the baseline hash, the initial baseline hash, and then we read every time we've audited or checked the baseline, and we determine if it's different. So as you can see, nothing has changed as identified by the green here. Now what if we change this test file? Let's go back to where our file is. We've got test file right here. So let's go ahead and change this file. Let's just say modified test file. And as you know, now the hash should change. Let's do an audit of this file. So that'll go ahead and take the hash of this new file, which should be different. Now let's detect if there's been any changes. As you can see, there has, which would be expected. So as you can see at 1047, the last time it checked the file, it noticed this hash does not equal the baseline hash. Therefore, it is not accepted. But files will change all the time, for good or for bad. If this is a malicious change, then we can go investigate why it occurred. However, if this is to be expected, right? If you need to configure your file in a way that you have to perform something differently, then this shouldn't actually be bad. This is fine. But what needs to happen is you need to say this new hash or this new file is the good version of what we want. It's the known good state. So what we need to do is promote this hash to be the new baseline. So then going forward, this hash is expected. So we have this built into the tool as well. This is our last promote function. And the promote function takes the baseline name. So let's go ahead and give that this test file. Okay, and it gives us a nice little banner. It says here's your configuration function. It shows you some information. It shows you the hashes and the numbers. And it wants us to enter number of baseline to promote. So that would be our new baseline of 3. And it says who's the new approver. Let's go ahead and say that is, I don't want it to be me, I want it to maybe be someone else. So let's say Billy. Billy's the new approver. Okay, so now it's changed. You can see we still got the same file to check, the name, the new baseline date, which just occurred, the new approver, and then the new hash. So now, let's run another audit on this file. Okay. Let's run another detect on this file. And there we go. You can see that the initial 3 have been ignored because they're prior to the new baseline. We have our new baseline, which we just approved or promoted, and then we have the audit or check that occurred afterwards. And all of this is stored in our JSON file. So we have a full audit history of what has happened every time it's been checked and audited. We have the new approver, we have the new baseline, and when that baseline was established. The file, the full file path, and the name. So this is a super easy way to check on sensitive files, important files, configuration files, really anything that you don't want to change over time. Again, this is called Secure Configuration Management, and this is what I implement on the EC429 server in order to detect changes and ensure the integrity of the files on my system. I will leave a link below to the GitHub repository where you can download and use this tool. Please subscribe and let me know if you have any questions in the comments below.